2.7 talks about derivatives and rate of change. Derivatives rate of change. So let's say we have a function f like this with a point q with coordinates a, f of a, and another point p with coordinates x, f of x. So the line connecting the two dots called the secant line. So q has coordinates a, f of a, and p has coordinates x, f of x. So the slope of PQ, we know it's a secant line, is the difference in the y's over the difference in the x's. And how do you find the difference in the x's? From here to here, that's an x minus a. From here to here, f of x minus f of a. So that's f of x minus f of a over x minus a. Again, that's the slope of the secant line. Connecting the points P and Q. Now, what happens is, if I take this slope that I just found, f of x minus f of a over x minus a, and pass the limit as x approaches a, so a and x, they get closer and closer to each other, this becomes the slope of the tangent line. Because what happens, the 2 points get closer and closer to each other, so eventually the secant line becomes a tangent line. Tangent line is the line that's going to touch the graph here at exactly 1 point. So this becomes slope of the tangent line to the graph of f at q with coordinates a, f of a, provided that the limit exists. As an example, find the slope of the tangent line. So continue with this. Continue with this one. Find the slope of the tangent line for the graph of y equals f of x equals x squared plus 4 at the point 1 comma 5. Well, I have a point, I just need the slope to find the equation of any line. So the slope of the tangent line is the limit as x approaches 1 of f of x minus f of a, which is 1, over x minus 1. F of x is x squared plus 4 minus f of 1 is 1 squared plus 4 over x minus 1. Limit as x approaches 1. X squared plus 4 minus 5 over x minus 1. X squared minus 4 over x minus 1 equals the limit as x approaches 1, x minus 1, x plus 1. So this would be 2. So we found the slope, and remember they only ask us to find the slope. If they want us to find the equation, we can continue by finding y minus y1 equals m times x minus x1. some people look at it in a different way. You know how we found the limit and of x minus f of a? Let me draw the function again one more time. Pick a point here, x and f of x. And pick another point here. I'm gonna move an h distance, so x plus h. This means this point has coordinates x plus h comma f of x plus h. So the slope of the secant line through the points x f of x and x plus h f of x plus h is given by fx plus h minus f of x over x plus h minus x. So what I'm doing y2 minus y1 over x2 minus x1. This simplifies to f of x plus h minus f of x all over h. Now for these 2 points to get very close to each other, I have to do something about h. What can we do about h? We can take the same, this is called difference quotient, we learned it before. If you take the limit as h approaches 0, as you make h goes to 0, this gives us the slope of the tangent line. To the graph of f at some given point. Find the equation of the tangent line to the graph of y equals 2x squared minus x plus 5. Using what we just showed you about the slope of the tangent line. Here they ask us about the equation. So we need to first find the slope of the tangent line, which is the limit as h goes to 0 of f of x plus h minus f of x all over h. You can use the previous equation or formula, that's fine, but I'm just showing you an example on this one. Limit as h goes to 0. F of x plus h is 2 times x plus h squared, x plus h plus 5 minus 2x squared minus x plus 5 over h. Two x squared plus 4xh plus 2h squared minus x minus h plus 5 minus 2x squared plus x minus 5 all over h. This cancels this. Negative 5 cancels, x cancels. Before we pass the limit as h goes to 0, take an h out. You get 4x plus 2h minus 1 all over h. These cancel. So that gives us 4x minus 1. We need to find it at the given x value, which is 1. At x equals 1, the slope then becomes 4 times 1 minus 1, 3. That's the slope of the tangent line. Okay, so we found the slope. Now we use y minus y1 equals m times x minus x1. The y value of the point is 6, the slope we found 3, and the x value is 1. It would be nice to rewrite it, 3x minus 3, and add 6 to both sides. Okay, so we can look at more examples similar to this and see how it makes a difference. For example, we're going to find the same for y equals 2 over x, that's called f of x, at x equals negative 1. So first we try to find what f of x plus h minus f of x over h is. I used to do that when I was a student before I start getting with the limits. It's 2 over x plus h minus the function itself all over h over 1. The LCD is x times x plus h, x times x plus h, x times x plus h. And what is going this to give us? 2x minus 2 times x plus h all over x h times x plus h. What is left on the top? 2x minus 2x minus 2h. Keep the denominator the same. Keep the denominator the same. The 2x cancel. Then the h cancels. So that gives us negative 2 over x times x plus h. And what we need to do here is to find the limit of this thing we just found as h goes to 0. That gives us negative 2 over x times x plus 0, negative 2 over x squared. Then the slope of the tangent line is this answer we got at x equals negative 1. It's given. Negative 1 is given. So if you plug that in, negative 2 over negative 1 squared, that's a negative 2. That's the slope. And to finish solving this, you got the slope and you got x equals negative 1. You just need to find the y value, 2 over negative 1, negative 2. So I have the point, negative 1, negative 2. We have a point and a slope. What we can do, we can find the equation of the tangent line using y minus y1, m times x minus x1. Y minus negative 2, slope is negative 2, x minus negative 1. Y plus 2 equals negative 2x minus 2. That's the equation of the tangent line. Now we may start defining what a derivative is. Derivative of a function f at number a is denoted by f prime is the limit as h goes to 0 of f of a plus h minus f of a over h, provided limit exists. And to apply the definition, we need to find the derivative of f of x equals 3x squared minus 4x plus 10. Okay, we just have to find the derivative here. By finding the limit. Replace x with x plus h. So 3 times x plus h squared minus 4 times x plus h plus 10 minus the whole function. I always use parentheses for that. Three x squared, 6xh, 3h squared, minus 4x minus 4h, plus 10 minus 3x squared, plus 4x minus 10 all over h. These cancel. Take an h out, 6x plus 3h minus 4 over h. These cancel out. So if we pass the limit to this, gives us 3h minus 4, 6x minus 4. So that's the derivative for this function. If you like to try one similar to this, same for f of x equals negative 2x squared plus 7x plus 1. Try this one for 3 minutes. Okay, we continue with this, hoping everyone tried until the end. Limit as h goes to 0 of f of x plus h minus f of x all over h. H goes to 0. Negative 2x plus h all square plus 7 times x plus h plus 1 minus the whole function. Minus 2x squared minus 4xh minus 2h squared plus 7x plus 7h plus 1 plus 2x squared minus 7x minus 1 all over h. These cancel. 2x squared cancel, minus 1 cancels. Then we can take the limit as h goes to 0. We have h out, we always factor h out, negative 4x minus 2h plus 7 all over h. So then these cancel. As h goes to 0, you get negative 4x plus 7. That would be the derivative for that function. Now in chapter 3, later on, we will teach you shortcuts. We'll teach you shortcuts for sure. You don't have to do all this work. So next, as an application to derivatives, if a rock is thrown upward on the planet, okay, Mars, with a velocity of 10 miles per second, its height in meters, actually that's meters per second, after t seconds is given by h equals 10t minus 1.86 t squared. Let's call it a function in t. Part A, find the velocity of the rock. Velocity of the rock after 1 second. Okay, that's what we're gonna do first. So to start with this one, the velocity at t equals 1, which we'll come back to it here, is going to be v of 1. V of 1, so at that instant is going to be the slope of the tangent line, basically. H goes to 0 of f of t plus h minus f of t all over h. T here is 1, keep that in mind. So we're going to do the limit as h goes to 0. So it's going to be f of 1 plus h. So substitute into the function t 10 times. Instead of t, put 1 plus h minus 1.86, 1 plus h squared minus the whole function, minus 10t plus 1.86t squared all over h. This equals the limit as h goes to 0. We have 10 plus 10h minus 1.86 minus 3.72h minus 1.86h squared minus, remember t is 1, so that's a minus 10, and there's a 1 there, plus 1 point something, so it's a minus 8.14 all over h. So things cancel out. 10 minus this and this cancels the last one. So now we can take an h out on the top, and that will leave 10 minus 3.72 minus 1.86h all over h. These cancel out. And now remember the h goes to 0, so that's 10 minus 3.72, and that'll leave 6.28 meters per second. That's what we have. Next, part B, find the velocity of the rock at t equals a. So since they talk about the velocity that we found earlier, we found that v of t was 10 minus 3.72t. That's what we found. So at a, v of a would be 10 minus 3.72a. That's all you have to do. Meters per second. Part C. When will the rock hit the surface? Hit the surface, this means this occurs when the height is 0. So this means the given height, which is 10t minus 1.86t squared, is 0. Take a t out. 10 minus 1.86t equals 0. That means when t is 0, or when 10 minus 1.86t equals 0. So t is about 5.38 seconds. T equals 0, that's, at the moment, right before you throw it away, it was at no height. With what velocity will the rock hit the surface? Well, the rock will hit the surface at what velocity? We know the velocity is 10 minus 3.72t. It will hit the surface at t equals the one we just found, 5.38, right? So that's where the height is 0. So it's gonna went up this way. That's when the height is 0, when t, after t passed after 5.38 seconds, the rock hits the surface. So they're saying, what's the velocity when the rock hit the surface? Means, what is the velocity at the moment that the rock hit the surface? Means, what's the velocity when t is 5.38? So all we have to do is substitute that in. It's more of an algebra. And if you calculate, that's about negative 10 meters per second. Any questions about this section?